In this video, we're going to give a high-level overview of data programming. So we'll talk about the principles behind data programming and why they're beneficial, and then we will go into some examples. Sound good? Let's get started. So let's just start from first principles. So if you decompose what it means to have high quality labeled data, well, there's three things you need to consider: the quality, the cost, and the speed. These are the most important variables in the real world. And if you really think about it, when you're labeling data to program software 2.0, if you want higher quality, well, then you need just smarter labelers, or you need more labelers of roughly equal intelligence. There's really no other way around it. It's not easy to do that, but there's really no other way around it. And similar with speed, you need faster labelers, or you need more labelers working in parallel. And same with the cost. The only way to ultimately get to a low cost is you need cheaper labor, cheaper labelers. And so that may sound very obvious, but from a lot of people I talk to, it's not necessarily obvious. So I apologize if this slide was extremely obvious, but I just wanted to get on the same page with that. So let's talk about how data programming influences these three variables I just talked about. Well, the first secret and the first insight we had was that of the assembly line, which we realized solved a lot of these problems and was really aimed to optimize these three variables of quality, cost, and speed. So what do we mean by this? Well, what an assembly line does is it breaks down a complex task into an amalgamation of simpler tasks, isolated simple tasks that are somehow connected in what we use graph theory, but in an assembly line they're connected in another way, which you could model with a graph, with a DAG, directed acyclical graph. And so the power of this is in terms of cost. You get a massive cost savings, because when you have these simple isolated tasks, the skill you need to complete them is much less, and therefore the price you need to pay for the labor is much cheaper. So that's one. The other thing, which is along the same vein, is you can automate this with machines, with AI. So in the case of the car assembly line, if you asked a robot, at least with today's technology, to assemble the whole car, they just couldn't do that. It's beyond the scope of the current skill set of robots. Whereas if you ask a robot to put a mirror on a car, they can do that. And in fact, they do that every day. And it's the same idea here. So if you asked an AI to solve this complex task, most likely it's beyond the scope of what the AI can do. We're in the world of narrow artificial intelligence and machine learning. Whereas if you ask an AI to do a very simple task, because we're in this world of narrow AI, this works really well. And in fact, I'm often confused when I hear labeling companies or labeling tools trying to automate the whole end-to-end complex task. That doesn't make much sense if you think about it, right? Because if you can have an AI that's good at the end-to-end tasks, then why would you need to label data? Just use that AI. Yeah, so the first benefit of data programming is you get this massive cost savings, because we built this programming language on top of labeling primitives to be able to make it very easy to decompose it into simple tasks. The second benefit is you get a huge increase in quality. And so because you have these simple isolated tasks, this, going back to Adam Smith even, specialization, you get a specialization of labor. So you can have one of these narrow AI or a human just focus on a very specific task. So for example, drawing a bounding box on a very isolated piece of an image. So this is equivalent to someone putting a tire on a car. So you could put a tire on a Toyota or a Mercedes or any car. And so this is the idea of transfer learning on, just as in the bottom layers of convolutional neural networks, they're detecting edges and textures. Well, the same is true here. You get this massive benefit of transfer learning. And the final reason why it increases quality is because since the tasks are simpler, people make less errors on them, which therefore increases the quality. So we talked about a huge increase in cost, a huge decrease in cost, and a massive increase in quality. But the third piece is you get a huge increase in scalability and speed. So one is the simplicity of the tasks makes it much easier to train people. Those of you who have labeled data know this pain firsthand that you spend a lot of your time educating your labelers, maybe even 80% of your time. And we talked about that because labeling is subjective and there's a lot of edge cases and you need to iterate based on your learnings. And so this makes it much easier to scale because it makes it much easier to train people. And the second piece, which is not surprising, is you can automate this with AI, which is much faster and much more scalable. And finally, those of us who use machine learning in the real world know you ultimately need to debug. And so since these tasks are isolated, it's easy to understand where errors happened, fix the isolated piece, continue iterating, and move on. And all these things massively lower the output variability, which is really important in the real world. And this is one of the main benefits of the assembly line. And so what essentially we've done is we've taken the core principles of Adam Smith and Henry Ford, and we combined them into a Turing complete programming language. So it's pretty cool, right? But that's the idea of data programming. And so let me just give you some concrete examples of where we've seen a huge change in quality, cost, and speed by applying data programming versus using the traditional approach of programming software to applications. So one of the first applications we applied this to was meeting summarization. So we worked with LogMeIn. They're a big multi-billion-dollar public company with 1,500 employees, and they have video conferencing products such as Join Me, GoToMeeting, GoToWebinar. And what they wanted is they wanted this value add feature to their customers where when you get on a meeting, you can have the meeting automatically summarized. Like, for example, what are the takeaways, the action items, the sentiment of the meeting, and you get a textual summary of the meeting. And so they tried doing this in the traditional way, but it just didn't work. And so what we did is we decomposed this into small tasks, just like an assembly line, using data programming. And so I'll just show you what these were. So the first thing we did is we took the audio and we broke it down into little chunks. They were typically 5 seconds long. And then what we did is we whitelisted the clip. So did the clip have any meaningful semantic information in there? And we did this all in the audio domain. And so when the clips got whitelisted, they were transcribed, and they went through a task where people added context, so who, what, when, where, why. That's not shown here. It was transcribed, and there was a few other steps, but ultimately it then got combined into a summarization over the chunk, and then each of those chunks got amalgamated into a final result. And here's an example of that. So that was an example of where data programming was very successful and just took it from an unusable product to a product that was in production. We actually handled all their production traffic. Another example is in the self-driving car regime. So typically how someone would label this data is they would send this video to someone and or maybe a few people and expect them to label each frame, whereas this is really intense, soul-crushing work. Whereas if you did this using the data programming paradigm, well, maybe what you would do, and this is what we've actually done for our self-driving car clients, is you group these into semantic frames. So this is very similar to chunking the audio, but you group these semantically. And then what you do is you take each one of these chunks and then you annotate the key frames. So you find these frames that have a large support over these semantic groups, and you further decompose these, and you only have a labeler label one at a time. It's not shown here, but you would say, okay, label one car, or label one bicycle, or label one street light, and you would send that to multiple people. And then you would QA that. So you would make sure that each of these labels would good. You would combine them, and then you would propagate these annotations over these semantic groups. And you would iterate on this over and over again, and ultimately you would finally combine this into a final video. And this gives you really, really high quality. And our customers have been really satisfied with this. Okay, so those were some examples of how you decompose it. I'll quickly go over some actual data programs. We won't go into the decomposition, but a lot of our customers use this for document understanding, and so you just get a totally different level of quality, cost, and speed in this. You have semantic entity tagging, so a very common use case for this. And one of the powers of data programming is you can even take these building blocks, so for example, entity tagging, and you could combine them into even more complex data programs. And so you have this abstraction capability that is very powerful, and we see our customers use this a lot. We handle relationship annotation, chatbot intent variation. So if you're training a chatbot, you want it to be very robust. And so if you see one of your customers asks you, how long is your store normally open? Well, you can anticipate people are going to ask things like, what are your business hours? What are your hours of operations? What are your store's hours? So you want your chatbot to be able to handle that. And so this is a common use case. Object detection, no surprise there. Audio understanding. So you take this unstructured audio and you create a structured detection out of it. So what is the gender, accent, etc. Or you can transcribe speech, and you can do it phonetically. You can remove the ums, or you can do it exactly how it was. Our customers ask us for 3D annotation of satellite and drone data. So these are cuboid annotations, object detection, image annotation, whether it's cuboids, ellipses, polygons, etc. Semantic understanding of video, video annotation, text classification, so categorizing emails or conversations into support routing applications. Query relevance, again, another chatbot application. So was the response I give to my customer, was it relevant? Or we work with some of the biggest search engine companies about, are the responses they're giving to their clients relevant? Web scraping, etc. So that was a brief overview of data programming. In later videos, we'll go into even more detail and show you exactly how to write a data program and the infrastructure of data programming. But in the next video, we're going to give an overview of the AI compiler. So see you there.